Hello everyone, this is Math Days again, and today we're going to be doing a full review of AP CSA, start to finish. And this review will cover, or should be covering most, if not all of the important topics you need. But after this review, we still recommend you go do some practice problems and review topics separately that you did not quite understand. So first we're going to start off with Unit 1. There are 8 primitive types in Java. Java, the coding language, is object-oriented, and there are 8 primitive types. These include int, double, and long. Int stores integers, double stores decimals, and long, this is not really on the CSA exam, but I just include it. Long store really large integers that 32 bits cannot store. And a reference type refers a class, which can be custom or not. Like a string, for example, is a reference type. A string can also be used as an object, and you can create other classes to make objects. This will be covered more in depth in Unit 5 when we get there. So variables are used and declared to hold values. For example, this is me declaring an int variable called total cows, and I'm setting it initially equal to 0. This is how you declare a variable. You can do it with any other primitive type or any other object for that matter. And at the end, you have to put this semicolon. And you can also add final before the int, just this final. And yeah, Java is case sensitive, as most programming languages are. You need to have the exact word, lowercase and uppercase. So going back to the final thing, you can add final before the int to make the variable unchangeable. Otherwise, you can still adjust total cows. And yeah, semicolons are required after almost all Java statements. So now I'm going to talk about arithmetic in Java. So double is a decimal and ints are whole integers, and they're used for math-related expressions. And these are some of the expressions you can use. Addition with a plus, minus with the negative sign, division or multiplication, or even mod. Mod gives the remainder as shown. 5 mod 4 is 1. And for integers and double values, you can use, and even booleans and characters, you can use equal to compare the values. Like this is checking if the values are equal or not. Because you know how, I'm just gonna go back for a sec, you know how use the equals to a sign? To compare, you need to use double equals. And you cannot divide by 0 as an error will occur. So now I'm gonna go over some basic errors in code. Syntax errors will not allow your code to compile. For example, if you forget a semicolon, you might see a red dot in your IDE, and that won't allow your program to run. Compile time errors cause an error when you run your code. Maybe in your for loop, which we will go over later, in the for loop, you're accessing an element not in the bounds. So then there's no element that exists. That won't cause a syntax error. You can still run it, but as you run it, the compiler will detect an error. And a runtime error is when your code will output the wrong value. So Java operators. Here are a few operators that you can use. Let's say there's a variable named a. You can use plus or equal 5. The AP exam might display this, plus or equals 5, and that just means you add 5. It's the same with negative, a multiplication, division, and mod. You can do a plus plus, that increments by 1, and a minus minus decrements by 1. And now we're going to go over casting. Sometimes you can cast variables to another type. For example, here, casting this double 3.8 into an int will result in 3. So whenever you cast doubles, you always just remove the decimal point. So 4.8 turns into 4, negative 3.4 turns into negative 3. And max integer and min integer values can be found by using integer.maxValue, integer.minValue. Basically, these values are the max and min values that any int type can store. If you want to store a value smaller than that or larger than that, you need to use longs. And otherwise, you will get an overflow error if you access values not in that range using integers. But longs are not in the scope of AP CSA, so you don't have to worry about that. Now we're going to go on to Unit 2, using objects. So what even are objects and classes? An object is just an instance of a class with attributes. A class, think of it as like a blueprint. Like, let's say you have a house as a class. It's a blueprint to create a specific object, a house. And here's another example. Let's say there's a class dog, and the object is Bessie, and Bessie is also a dog. Bessie is the name of the dog. And to declare an object, you need to use a constructor. And that also instantiates the object. The constructor header must have the variables needed and the names. And this might be important, formal parameters are like the actual names of the variables. Actual parameters are the values. So for example, a formal parameter might be house size. The actual parameter might be 100 as the value for the square feet in the house. Now here are some examples in code. So this is a constructor with two variables. The first one, the cow one. The formal parameters are numCows and time. And let's say I create an object cow here. The actual parameters are 5 for numCows and 6 for time. And you can just ignore this part. I'm basically putting it in an array, which we'll go over in Unit 5 or 6. The code on the left is considered calling the constructor. So actually, it's an error. The code on the right, like this thing, which I'm hovering over right now, that is calling the constructor and initializing the value to cows. And yeah, just ignore the cows at I part. We'll cover it later in the video. So methods. In Java, you can create methods which are used to do certain tasks. And methods have certain functions that your code needs to do. For example, a method could be finding a value in a set, or a method could be finding which value is the largest in a set. Now I'm going to continue talking about methods in Java. This is there are two types of methods in Java. Well, actually, yeah. So static, I'm quickly going to go over static. So static means that it's not used for objects. It's just used normally in the main class. And if you don't put static, then that means the method is used for objects. And for either of those types of methods, static or non-static, you can either have void methods or non-void methods. Void methods don't return a value. Non-void methods return a value. So for void methods, the declaration is still the same for both. And yeah, this is how you declare it. So what returning means that the method, when you call it, it'll like produce a value in whatever you want to store it into. You can like print the value, store it in a variable, and so on. And if you don't return a method and you don't put it as void, you essentially put what you want to return, the type here. And we didn't really go over this, but so just generally make a Java file. You do public class and you put your class name, make it capital, and then below that you'll do public static main void. And then yeah, that's how you start it. But your class should have covered this, usually, most likely. So strings. So string literals are defined as just this. You can just put something in quotes and that'll be a string. And these are instances of the string class. And make sure, we're not really going to cover this, but make sure it's pretty easy. Just make sure you know the variable and class naming conventions. We'll put the link in the description, or you can just search up using Java naming conventions by .co. So string objects, they can be concatenated. That basically means you add two strings together. For example, here, what I did right now, string will now be string hi. String methods. So strings are not a primitive type. They are composed of characters, which is a primitive type, however. A string is just a list of many characters. So for example, the string hi has the char h at index 0 and the char I at index 1. The length of hi is 2. And here are some of the string methods you may or may not see, or most likely will see on the AP exam. So there's the length function of a string, which gives the length of the string. So since str is string, 1, 2, 3, 4, 5, 6, 6 characters in it. And that is the length of the string. And you can also use the substring method. Essentially what it does, you have two indexes, and it basically gives the string from the start index going to but not including the end index. So substring from 0 to 3, 0, 1, 2, 3. It'll just give str. And the index of method just gives the index of, or the first index of a character in a string. So here, the index of method gives 0 for s. But if there was a capital S at the end, it would still give 0 because it always gives the first index. It gives the first index of the character, just to be clear. So continuing on the string methods, you can use the str.equals method. This method compares two strings and returns true if they're equal and false otherwise. Here it's going to be true since we set str to be string. And the compare to method, essentially what it does, it returns the ASCII index of string minus the ASCII index of str here. So what is ASCII? ASCII is essentially, Java has the system where it assigns numbers to every single character there is. So what it does is that since str is this string and this str is just str, it'll first compare the first two, then if the first one is bigger than the next one, then it'll return a positive value. If the first character has a higher ASCII than the first character of the other one, it'll return a higher value. If they're the exact same character, it just keeps going on until it reaches the end. If it reaches the end, then it returns 0. Now I'm going to go over escape sequences. So in Java, if you want to insert certain stuff like a single quote, double quote, backslash, you need to use the escape sequences. Essentially, this is how you do it. For a single quote, you need to do a backslash and a single quote. Double quote, you need to do a backslash and a double quote, like in case you want to print something with the single quote or double quote. And if you want to insert a backslash, you need to do two backslashes. And to create a new line, you can do /n. These are used to output special things in Java. Now I'm going to go over the wrapper class. Okay, so the wrapper class, what it does is it makes it possible to cast primitive types such as ints and doubles into objects to be able to use object methods. It's not too important for the exam, but remember these few things. The Java compiler automatically converts primitive types to the wrapper class alternative, and this is known as autoboxing. And unboxing is converting the wrapper class to primitive type. Here, for example, you have this int z, you convert it to an integer, which is part of the wrapper class, and you do this, the value of. And it still has the same properties as an int, except you can add it to different types of data structures, which we will cover later, such as an array list. The math class. The math class is, in Java, the math class helps users perform math operations, such as finding the absolute value by using abs, getting the power of a number, or squaring a number, whatever you want to do, cubing, by using the PAL function, and the random method, which returns a random double from 0 to 1. So the random method is interesting. It returns a random double from 0 to 1, but in the AP exam, most of the time what they do is they multiply that double by a certain value, and they cast it to an int. So let's say I multiply that value by 5, and I cast it to an int, then what is the range? The range is a number from 0 to 5, but not including 5, since the math.random never includes 1. It's 0 to 0.99999, any random double. But since you're casting it to an int, the only options are 0, 1, 2, 3, 4. And now I'm going to go over if statements, the third unit. So what are if statements? If statements are used to compare certain values. So what are if statements? If statements are used to compare certain values. So what are if statements? If statements are used to compare certain values. For example, equal equal and not equal are used to compare integers. Equal equal will return true if two integers have the same value and false otherwise. It's the opposite for not equals. You can also use these comparators to compare integer values. And whenever there is an if statement, it has to be in this format. If something in parentheses, and then you have your condition, what you do here. And you can also add an else statement if the if statement after the if statement. This else statement will only run if the if statement becomes false. Now I'm going to go over else if statements. If you have an if statement and you want to have an else, but there are certain conditions within the else, you can use the else if statement in Java. The else if statement runs if the first if it is not true, if the else if condition is true. So the first if statement is not true, but if the second else if statement is true, then it'll run here. And you can also have an else after all of the else if statements. And you can have as many else if statements as you want. So now some more stuff on if statements. You can actually nest if statements. So you have this outer if statement, and then if it's true, you go in here. And there's an inner if statement here. If that's true, then it goes even more in. You can also add more complexity to your if statements by using the two and signs. This is and, or the two or signs, which means or. So for example, you can do if num is equal to 1 and num is not equal to 100. Or you can do if num is equal to 1 or if num is equal to 100. Either of those you can do in Java. So De Morgan's law may also be tested on the AP CSA exam. We're not really going to cover it since it might only be on 1 or 2 questions, but you might want to look into that after the video. So some data types like ints and chars, you can use equal equal to compare for equality. But for other classes like string, you need to use the equal statement, as shown here. Now we're going to go over loops in Java. So there are generally two types of loops in Java: for loops, which will run for a certain amount of time, and while loops, which run until a certain condition is met. And all loops, all they do is reduce code that needs to be repeated. For example, this first loop, it runs 7 times from I equals 0, 1, 2, 3, 4, 5, and 6. When it reaches I equals 7, the loop will break, and it will always run 6 times. And a tip, try always running the code and write down every time what the I variable is and what's going on in the main loop. Also, you can use while loops. This while loop, sorry, I don't know why I put a for loop, but this while loop will run until both conditions are not true. And while loop conditions have the same rules as an if statement condition. So while end is less than n, and sum is not equal to x, it'll run. But if one of them goes false, then it'll stop running. So the use of loops. One cool thing you can do is iterate through a string's characters. This is how you do it for both cases. For int I equals 0, I represents the index of the char, and you go less than equal to str.length, and then you always get the character at that index. And you can also do the same thing with the while loop, but you need to have a separate index, and every time you need to increment end. Finally, nested loops. I think finally. Yeah. Okay, finally nested loops. You can have a for loop inside another for loop, and while loops inside other while loops, and even a while loop inside a for loop, or a for loop inside a while loop. Here's just a small example with the for loop. So this is how it will run. It will run from first I is 0, then j is 0, j is 1, j is 2, all the way to j is 10. And when j reaches 10, then I is 1. And when I is 1, j was 1, j is 2, j is 3. It goes all the way up to 9, and then I is 3. And then the same thing happens. So I doesn't move until j is finished moving. Only then I moves and j goes back to the starting point. Now I'm going to go over writing classes. So the keyword public in classes means outside of the declaring class, the class can be accessed. Private means only the class can access stuff inside the class. Classes are generally declared as public, while variables or attributes, they're the same thing, are declared as private. And constructors, I'll show you how to write a constructor, and those are used to create an object and will be public. Method, generally you can make them either private or public. If it's important information, generally make it private. Not important, make it public. And the AP exam might add both of these, private and public methods. So constructors. Constructors always have the same name as the class. For example, here, let's say you have a class named log. The constructor will just be public log, same capitals. And then these are the variables you need in it, and then you'll initialize the variables inside. So states are the same thing as attributes and variables of the class. And when no constructor is written, Java always provides a no variable constructor. And one more thing, with comments, you can add English code and describe code without the compiler detecting it. So this / can add information to someone reading the code on how the code works. And the compiler is just going to ignore it. You can also use this, as shown here. This slash and an asterisk, you need to have an asterisk and a slash at the end, and you can add whatever you want inside here to make it work. Or not make it work, to show someone reading the class. So there's generally two types of methods that you might need to know about. Accessor methods simply just return private values in a class so other objects can use the designated value because these values are private. So you set the variable to be private. So if someone outside the class in a main method wants to access that variable, you need to use accessor methods like this. This just returns the time. Some other classes might contain a toString method where the method prints out values of a class, like all of the variables of a class. You just declare the method as toString, and you can probably do more research on this afterwards, but you declare the method as toString. So whenever you do system.out.println and then you put the object name, it'll always print out the variables. And mutator methods are usually void, they just modify variables. Like this is a mutator method, it's just modifying time. Okay, So methods can access all variables in the class, even if they're private. And we already went over actual and formal parameters, but here's some more examples on it. Static methods are not associated with classes. Static is used like this. You put the static here. But since these are associated with classes, there's no static here. So local variables are declared inside a method or class, and they can be only used in that section. But global variables can be accessed from everywhere. So one more thing you need to know. So this is generally what inside a class looks like. You'll have some variables here, and then you have the constructor, and you initialize the variables inside the constructor. You can use the this keyword to access it, because like both of these are time, both of these are ID, both of these are change. Java doesn't know which one is from the class, which is from the method. So you need to use this dot, and that will put the time from the class, not the time from the constructor. Or you can just have different names for these variables. So final thoughts on writing classes. You might have an FRQ on writing a class from start to finish and a few MCQs. So be sure to practice past FRQs, then the MCQs will be easier on writing classes. So Unit 6, arrays. Arrays are used to store certain value of some type, and it can only be one type. For example, you can have an array of integers, which is like a list of integers. An array has indexes 0 all the way up to n minus 1, and it stores values. So this is a customer's array of size m. So the indexes are 0 to m minus 1, and this is the first part on how you declare an array. And you can initialize the values of an array by doing customers at some index 0, 1, 2, 3, 4, 5, 6, all the way up to m, or m minus 1, equals a certain value. So transversing an array. You can traverse an array's value at a certain index by using the array at index x. That's how you access the value at that index. You can also use a for loop or while loop to access each element in a row. For example, this for loop goes from 0 to n, which is probably the length of the array, and at every point it accesses the value at that point, and that's a customer. You can also use an enhanced for loop like this, for in customer in customers. This accesses every customer in the customers array. And when using this, you cannot adjust the value. You cannot just change customer equals 5, for example, or customer equals 10. That will not change the value in the actual array. But here, what you can do is customers at I equals 10, or customers at I equals 11, and that'll actually change the value in the array. But for the enhanced for loop, you cannot do that. The final thoughts on arrays. It's an important topic. You need to be really comfortable with it and practice doing methods and know how to create and traverse an array, and you should be good. It's not too hard to master. So now I'm going to go over array list, which is a pretty similar topic to arrays. Array lists essentially just store elements, and they don't have a specified size. You can keep adding elements for a long time. This is how you declare an array list. Sometimes, if you do not specify a certain type of an element to be stored, the array list can store types of every single element. There are many array list methods that you need to know. The get method at a certain index, you do get index, it'll return the value at that index, pretty similar to accessing an array's value. The add element adds an element to the end. The add index comma element adds that element to that index and moves everything down by 1. The set sets the element at that index, and it keeps everything the way it is after you set the element. So other array list methods. ArrayList.size, the name of the ArrayList.size will return the size of the array. The dot get returns the element. We already went over that. The dot set. Also, you can, using the dot set method, it'll also return the element which was replaced while setting the new element. So call the methods like another object on an array list. So yeah, on an array list, just call all the methods like you would as a string or as another class or another object. And you can still use the for each loop to traverse an array list, but you have to use integer. You need to use this integer element and use the colon and then array list name, just like an array. You can also use the while loop or for loop to traverse an array list. And finally, one cool thing about array list versus arrays is that you can remove an element from an array list, but you can't do that for an array. So final things about array lists, you can search through an element of an array list by iterating through it, just like an array. You can also sort an array or an array list. For arrays, you need to use arrays.sort. Array lists, you need to use collections.sort. And be sure to know these algorithms. We won't go over them because they're somewhat complicated, but you might get a few questions on the selection sort, insertion sort, merge sort, and binary sort. And finally, use arrays if it's a known size. Use array list if the size is not known, and you may want to change the elements. 2D arrays. So 2D arrays are essentially just an array of 1D arrays, and it can be thought of like a grid. Each location is accessed by a set of indices or points. This is sort of like a 2D array. How you can visualize it. This topmost point is 0, 0. Then you access this element by doing array at 0, 0. This one array at 0, 1, array at 0, 2, array at 0, 3. And here you do array at 1, 0, array at 1, 1, array at 1, 2, array at 1, 3. This is how you declare an array. This 2D array will have 0 to 9 row indices and 0 to 9 column indices. So major order. Row major order is when you start at a row, you start at a row, you go through each column, you go through each element in that row, and then you move down to the next row. You go through each element in that row, you move down to the next row. You go through each element in that row, you go down to the next row. Column major order, you start at the first column, you go through all the elements in the column, you move to the next column. You go through all the elements in the column, and you go to the next column. Let me just show you. Let's say this is a 2D array. Row major order, you'll start here, you'll go here, 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 then you move to this one, and then here, here, and here. Column major, you start here, you go down, next column, start here, go down, next column, start here, go down, next column, start here, go down. So the length of the columns, the number of columns, is just the 2D array, whatever the name is. I just said the 2D array name is ARR. You do ARR at 0.length. So back here, array at 0. Since a 2D array is just an array of arrays, it's just the 2D array, the 0th 2D array, that length. And that is the length of the columns. The length of the rows is just array.length, since that's the number of 2D arrays that exist. Not 2D arrays, that's the number of 1D arrays that exist in the 2D array. So here's just some quick code on the row major, column major order, how to traverse it. I think you can also use the enhanced for loop for traversing a 2D array, but you can only use it in row major order. This is how you do it. Int array row in the 2D array, and then you go through each element in that row. And in column major order, you just need to switch the loops. You just need to go through all of the elements in the all of the columns in the 2D array and then go through all of the elements individually here for column major. But these two are for row major. And you can't really use column major you can't really use a for each loop for column major order. Okay, next topic, inheritance. So Java allows classes to be extended and have the same methods and variables of another class. But you need to use the extends method for this class. For example, here's just a regular class that I created as a private int weight, private boolean is currency. This is the constructor, this is the accessor method, another accessor method, and this is a mutator method. So let's say I want to make another class called supercow. All I do is put extends cow. And essentially what it does, supercow now contains everything in here. It contains all of the methods, all of the methods, all of the variables, and yeah, you don't have to write it in cow. It automatically stores it. But you still need a constructor, even if you use the extends keyword. But what you can do is, you still need a method, this constructor method. What you can do is you can use super. Super, what it does, and you put the variables you want to. Essentially what super does is that it calls the previous constructor of the subclass. It'll call this constructor. It'll assign those two to those two variables. And then if you want, you can have another variable here and still assign it. And these are two different constructors. So this super cal can access cal's stuff, but cal cannot access super cal stuff. So super continued. So in the super class, if you want to access and use methods from the subclass, you can do super.methodName and put the variables that it needs. Or you can just use super as shown here for the constructor. But for the methods, if you want to access let's say you want to access the change weight method in the class itself, you can do super.changeWeight and put in the addend and it'll adjust the weight. So here's a main class for the two classes. So here, cow is just a regular cow created. Cow2 is a super cow created. And what I can do is, since cow2 is a super cow, and I didn't write anything, but I put the extends keyword, cow2 is a super cow, I can still use the change weight method. So initially the weight of cow2 is 0, but I use the change weight method to 100. And then if I print out the get weight, I did this myself, it'll output 100. Even though, that's the cool thing about extends, even though in the supercal, I did not specifically put the change weight method, the fact that I put extends here and the subclass cal contains it, it gets changed still. Last unit. So recursion. Recursion is usually a few questions, max 3 to 4 on the exam, and they might only occur in a few MCQs. I think sometimes they only occur on one or two MCQs. And they won't occur in any FRQs. So what recursion is just calling a method inside another method. So for the MCQs on the AP CSA exam, you really just have to run it by hand and keep track of the variables each time, keep track of every time a new method is called, and so on. You can use recursion for binary search on an array or array list to find the certain index of an element. And here's an example of recursion. This is, if you guys know the Fibonacci sequence, essentially the sum of the next value is just the sum of the two previous values. So here, what this method is doing, it's taking the value n, whatever n is. If n is 1 or 0, then it just returns 1. If not, it returns fib at n minus 1 plus fib at n minus 2. So let's say we start off with 0. 0, it'll return 1. So fib at 0 is 1. Fib at 1 is also 1. And fib at 2, actually no, yeah, fib at 2 is fib at 0 plus fib at 1, which is 1 plus 1, which is 2. And this continues. So thanks for watching this video. I know it was long, and if you have any specific questions or something the video didn't make clear, I'll be sure to answer them in the comment section. Just leave the reply. I'll be sure to answer them. Unless this video gets too many views, or too many comments. But yeah, we should be able to answer most of the new comments that occur quickly. And thanks for listening. Let us know if this video was useful and what you want to see next.